welcome everybody to our Halloween special Howling at the Moon. We come to you from all different parts of Victoria. We have Terry in Melbourne, myself in Melbourne, Uncle Chester up in Bendigo, and Screaming Andy out in the west of Victoria near the South Australian border. And
hello.
He's brought with him a spider as well. So as usual, if you've got any comments or questions, please pop them in the chat, and we'll try to answer them as best we can. And I hope some of you have gotten dressed up, because we do have a membership available for the best dressed person that we'll give away. So pop your photo in the comment section and we'll judge those throughout the night. So Perry, I will pass it over to you, and you can start having a discussion with us about the moon.
Thank you, Mark. Good evening, everybody. Happy Halloween to you all. Hope you've got lots of goodies that you picked up in your baskets. Well, what can we say about the moon? It's bright tonight. It's almost full. It's not quite able to reach full phase until after midnight for most of Australia. So that means we won't be having a blue moon this month, but we will have a blue moon at the end of November. So no matter what you've read or seen online or heard from any broadcasters or television stations, there is no blue moon for Australia. For the Western Hemisphere, though, anything west of and including Perth, there is a blue moon for everyone from Perth all the way through to the Americas. By the way, I should explain that I'm wearing my first phase of the moon t-shirt. I really wanted to get dressed up in a Halloween costume, and I went to buy a white sheet so that I could put eyes in it, cut them out, and wear that for the evening to be a ghost and scare you all. But when I got home and I opened up the packet, I realized it was a fitted sheet. So no costume from me for this evening, and I will go and get my money back. Anyway, we're really fortunate to be able to have clear skies where our telescopes are. Some of us in Melbourne have got clear skies, but I believe Andy's got clear skies around. Where are you, Andy?
I'm in Lane Coop, which is about 6 k's from the SA border. Closest town is Edenhope.
Right, okay. And we've also got Noel up somewhere near Bendigo or in Bendigo. Where are you, Noel?
Just in White Hills on the edge of Bendigo.
Okay. Now, one thing that sometimes people misunderstand about observing the moon, you don't have to get out of town and find a very dark sky to be able to observe the moon, because you can do it from anywhere, even from the centre of Melbourne. You can observe the moon because it's too bright to be affected by light pollution. So you don't have to go anywhere to observe the moon. You can just step outside of your house, and here this evening you can just follow with us online using those telescopes in Bendigo and near Edenhope. Whose telescope is on right now, guys?
This is Andy's.
Okay. Is it possible to pull out a little bit, Andy, so that we can have the full moon to begin with?
I actually have Ron coming online shortly with the full moon. So
okay. So I'm hoping, it's difficult to tell from just this much, but I'm hoping we're looking at, is it Copernicus or is it Tycho?
I think that's Tycho.
Okay, Tycho in the right part of the moon. As we look at it, it's a bright young crater and it's quite large. I think it's over 90 or 100 kilometers in diameter. So that means if you're standing in the middle of that crater on the flat bottom of it, because of the curvature of the moon, you wouldn't be able to see the walls of that particular crater. The other thing you will notice about this crater Tycho here is there's a lot of what appear to be rays emanating from it. And this is material that's been pulverized during the impact that created the crater. So this is perhaps a small asteroid that hit the moon, throwing up material, pulverizing it. A lot of heat is transferred and a lot of the material melts. And as it gets thrown up, it becomes quite glassy and sort of, it looks a little bit whitish here or a bit grayish, and reflects during the full moon phase. That's the best time to actually look for these young craters with rays emanating from them from the ejecta that has been thrown up after the impact. Now, are we still waiting for the full moon?
Yes, we are. Yes, we'll be there shortly. I'm just waiting for him to jump in.
Okay.
And I've just seen a question for you to answer actually while we're waiting. Terence wants to know, I understand we always see the same side of the moon, but is it slowly turning, and will we over time start to see the other side, or has it, and will it always be this way?
Yeah,
we will not be able to see the other side of the moon from here on at all unless we go and orbit the moon in a spacecraft, because it is locked, tidally locked to the Earth. But if you were to observe the moon from the top, looking down from either the north pole of the moon or the other way from the south pole of the moon towards straight down, then you would notice that over the period of one lunation, which is about 28 days, which is the time it takes for the moon to complete one orbit, you will notice that the moon actually does spin on its axis, but exactly once to match the time that it takes to orbit. So we never actually get to see the other side of the moon because it's always facing us and will always continue to face us. But it would be wrong to say that it doesn't turn on its axis at all, because it does, but it matches its orbital speed exactly once, and the period of it as well.
There we go. Beautiful answer. So what have we got?
We should, because of the same thing, if I may, Mark, because of this particular fact, there is no dark side to the moon. So some of us are old enough to remember the Pink Floyd album, The Dark Side of the Moon.
One of my favorites.
It sold many millions of copies, but in fact it was wrong. So it would have been good if we could have got their old science teacher to collectively, but I suppose politically incorrectly, give them all one slap for getting it wrong. Because when it's new moon for us, the far side of the moon that we can't see is in fact experiencing the full moon phase. So it's incorrect to say that it's the dark side of the moon. The best way to think of it is that it's the far side of the moon as we look at it from Earth.
Now, just quickly, it looks like people can't post the photos of themselves dressed up to the chat. So if you want to send it through to the ASV as a message, that would be great. Then we can judge it that way. I do have Ron, but he's got a close-up view as well. No wide view, unfortunately, but he's got cloud passing through at the moment. So I think we're going to be short on full views of the moon for the moment.
Okay. Well, let's pan over to the left side as we look at this image, if we can. Now, is this mirror reversed, or is it?
This is as you would see it. So
okay.
Yep.
Okay. All right. So that was what I suppose we would call the eastern side of the moon, because it's closest to the direction of east. And over here, we've got some darker areas that before the invention of the telescope, people on Earth used to think that they looked like they may be seas or oceans on the moon because they look darker than the rest of the moon. In fact, the darker areas on the moon are basalt plains, and they are in fact younger parts of the moon because material has welled up from the inner parts of the moon and spread out over the surface, creating these basalt plains. And if you look through a telescope at the moon, you will see that these areas, in fact, aren't totally smooth. They do have some craters, but not as many as the other parts of the moon, which look silvery grey or a little bit whitish in some instances. And the basalt plains were given names like the Sea of Tranquility, the Sea of Serenity, the Sea of Crises. The Sea of Serenity is what we're looking at the moment, if you don't go too far down because we're moving away from it. The area which is, just bring it down a bit if you could. Yes, stop there. So the roughly circular or oval shape in the middle of the moon at the moment is the Sea of Serenity. And to about the 1 o'clock position of that is another large, darker area. If we can go to that, where the little cursor is pointing. Yep. And that area, stop there. Yep. That area is the Sea of Tranquility, all of that dark area above the Sea of Serenity, right there. Again, it's roughly circular, and that's the spot where Apollo 11 landed. It's in fact near the right there, just a little bit further to the left, Mark, if that's you doing that.
No, that's not me. That'll be Andy doing that.
Andy, yep, just a little bit higher up. Yep,
Here where that little white
about
speck is.
about there, slightly to the left there, is where Apollo 11 landed back in July 1969. And most of you weren't even born then. Unfortunately, I can't say the same thing. Now, over to the far left and a little bit higher, just a bit above that, yep, is the Sea of Crisis. So that is another one of the dry lunar seas, which are in fact basalt plains. And again, you can see that one is sort of almost circular as well, which kind of betrays perhaps a little bit that it may have been an impact which was a very, very large impact that may have created that and allowing material to well up from the center of the moon while it was still a little bit molten to create this basalt plain. How are we going with that full shot of the moon?
I don't think we're going to get one, unfortunately.
Okay.
So I think we're going to have to pan around with what we've got. But I do have Ron here, so I'm just going to add Ron into the stream. So Ron's dressed up as an Arctic explorer. So I don't think we're able to get a wide view of the moon tonight, unfortunately.
Okay, well, that's sort of wide enough.
Yeah.
Now, up near the 12 o'clock position, there's another dark area there, which is the Sea of Fertility. Can we get an arrow on that one, Andy? Yep, that round area again there, or roughly sort of round. So they're the main seas on the western side of the moon as we look at it. And on the right side of the moon, which is the eastern part, just before we move, if we go up to the top, there's another rain crater there, up there. Yep, and that is the crater Tycho. Again, another quite young crater and a lot of material or rays emanating from that ejecta from the impact. Some of it, in fact, even went all the way around the moon before it settled on the surface. So they're probably two of the youngest and largest craters, and also the most obvious rays are emanating from the crater Tycho and also Copernicus. And both of those craters are named after two quite famous astronomers from the 15th and 16th centuries, one of them being Tycho Brahe, who was probably the best observational astronomer prior to the invention of the telescope. And this particular one here, Copernicus, is of course...
I think that's Tycho there.
No, that's Copernicus. Tycho is the other one. From what I think it is. Can we go a bit lower? Unless...
Yeah, I think that one's Tycho there. I think the angle is just a bit off. There we go.
Okay. Well, it's difficult to tell with only bits of the moon.
Yes.
So there's Copernicus, because these ray craters look a little bit the same. So that one is Copernicus. A bit below and to the left of that one is Aristarchus, I think, or is it not Aristarchus? No, it is Aristarchus, way down, and Kepler is, it's a little bit skewed. Actually, that one is Kepler, and the one directly below
Copernicus, it's just a little bit off. Yeah, so I have a question for you, Perry.
Yep.
Why are the I can never say this word. I'm just going to call it mares. So prolific, mares, I know. So prolific in size on the moon.
The mares, the seas, because of impacts that have allowed material to break through the crust and form a new surface area, if you like, made out of basalt rock. Now, can we just go back to those two craters, if we may? Okay, stop there. The crater just to the left, further down where you were, that one. That one is Aristarchus. I sort of have to bend my head to see it. And the one at the 4 o'clock position from Copernicus is Kepler. Now, it's because Kepler and Tycho and Copernicus were all working at about the same time, or roughly within the same 100 years, that they all managed to get similar craters. But the one down at the bottom there, which looks very, very bright, that one is Aristarchus, and Aristarchus was the first astronomer, the first scientist to actually say that the sun is the center of the solar system and that the Earth is a planet and, like the other planets, orbits around the sun. That knowledge, however, from ancient Greece was lost for nearly 1,500, maybe 2,000 years. And Copernicus wrote about this idea himself, and he was the first one to do it after that long period since Aristarchus of Samos, which is where the earthquake occurred in the Aegean yesterday, actually, the same little island. That's where Aristarchus was born and worked on. Getting back to the Basalt Plains, the mares, the large one on the eastern side of the moon is incredibly large, and so it's not referred to as a mare or a sea, but in fact it's referred to as an ocean, the ocean of storms. Oceanus Procellarum. Now, try saying that fast after half a dozen whiskies.
No, thank you. I'd rather not. But that's a tough one as it is, even when you haven't had a drink.
It is.
So I think I might quickly swap over to Ron's telescope. He's got quite a good view there, a little bit brighter. He's sort of down in that same area at the moment.
Okay. Yes, it looks like the atmosphere isn't quite as steady, or there's cloud moving.
Yeah, I think there's a bit of cloud still in Ringwood. So we'll go back to, we'll jump back to Andy's, just because it was a big view, that's all. He's got a little bit of a wider view.
Now, the other thing that's worthwhile knowing about the moon, or some of the other things that are worthwhile knowing about it, is the fact that In the hour that we're going to be looking at the moon, say from 9:30 to about 10:30, it would have travelled 3,680 kilometres along its orbit. So it's really travelling at a super fast speed in order to be able to complete its orbit, which is let's see, it's about 2,400,000 kilometres. So in order to be able to go around the Earth once, its path, or it racks up 2,400,000 kilometres of travel in about 27, 28 days, which is very, very fast. Keep in mind the distance from the Earth to the moon on average is about 384,000 kilometres. However, tonight, because of the fact that the orbit is a little bit oval, it's not perfectly circular, the moon is farther away or close to the farthest that it can get from the Earth. And that's about 406,000 kilometres from the Earth. At its closest, it can be at about 356,000 kilometres. And halfway, or on average, as I mentioned earlier, it's about 384,000 kilometres.
Right. So just a quick one, Perry. We're going to do the raffle in a minute, and I'll pop Ron's back on the screen for the moment. But Andy's going to go and set up his a Canon camera so that he can get a wide full view of the moon for us.
That'll be excellent.
Just jump on it. So while we're doing that, I'm going to get the wheel of names going. Here we go. All right. So there was a raffle of a pair of binoculars, Saxon binoculars, 7x50s, if I remember right, Perry.
Correct. Yes.
So everyone who bought tickets is sitting in on this lovely wheel, spinning wheel of doom. And so I'm going to spin that now, and we'll see who has won. Bassam Chakali. So I will make contact with Bassam via email to let him know that he has won. And thank you, everybody, for entering the competition. We have some more raffles coming up in the next week or so to do with our next live stream over next weekend. Also, that's another $600 that's been raised to go towards our Pathways to the Planets. So that's all of that money raised from all the raffles is going to a Pathways to the Planets, which is great news. I will be posting a link to the donations page in the chat for everybody, for those who want to make a donation. If they'd like to make a donation, that's our All Abilities Astronomy project and All Abilities Telescope, and making pathways for All Abilities to get around the site. That's what we're aiming to do. So, now, what have we got here zoomed in on Uncle Fester's? This is, what have we got there?
This is, yeah,
Copernicus, up close and personal.
Yeah, and it was. I finally got moon in view here. It's between trees at the moment, so I figured I can find something and put it on screen. So quite happy to take suggestions for a bit of detail, and I'll go on my merry way and find that.
There we go, Perry. Any suggestions, and Noel will go and find it for you.
Let's see if we could possibly have a look at the crater Messier.
Okay, I'll probably need a bit of guidance on where might be. I've got a very basic map.
Messier is over on the western side of the moon, and it's in Mare, right near Mare Tranquillitatis. In fact, I think it's in Mare Fecunditatis, or the Sea of Fertility.
We're working our way there.
Yes, I'm just okay. So I know the one.
So
now,
while you're working your way there, I've got a question about that Natalie's asked about the pathway to the stars. It's pathways to the planets, and the idea is for us to be able to bring astronomy to everybody, whether you have vision impaired, mobility impaired, if you're wheelchair bound. For the elderly, for the younger children who can't get up the tall ladders through the big telescopes we've got. At the moment, the site is not wheelchair friendly. It's not really very mobility friendly. We're looking at getting some sealed pathways between the accommodation blocks, which already have disabled access toilets and disabled access apartments or accommodation for members. And then from there, obviously to the clubhouse and down to where all the telescopes are, and to a specific telescope that will be for people with limited mobility. We've also been able to do some 3D printing of star charts, so some Braille star charts and things like that. So, yeah, we've got a lot of things that we want to do. Unfortunately, we need a lot of money to do it. We're putting in some money. We've had some money granted to us from the government, but we're trying to make up the difference so that we can do everything we want to do up at the Dark Sky site. There we go. Back to Perry.
Okay, so right in the center there are two white spots, and they're sort of oriented in a 11 o'clock to 5 o'clock sort of direction. And if you look at those two spots, they're in fact craters, and moving down from the second one, the lower of those two craters, when the seeing is steady, we can actually see almost like a tail moving away from the bottom crater. And there it is. And it looks a little bit like a comet. And it's not by chance that it's called Messier, because in the 1700s, Messier, Charles Messier, or Chaka if you're an Aussie, Chaka Messier was a French astronomer who specialized in finding comets. And he also created a list of objects so that he didn't mix them up with comets, because comets moved in the sky and these other objects that he made a list of did not move. So he didn't want to confuse one with the other. But anyhow, this particular pair of craters and the ejector material that's been pushed out from them towards the 4 o'clock position, an object came in at a low angle, scraped the material out of the first crater and also the second crater and pushed it forward in front of it, squirting it out, if you would, to create what looks like a comet with a tail.
So, Perry, we have a question. It's a pretty interesting one. Are you excited about the most recent discovery of significant water resources on the moon, and what are the opportunities for us? I did a little bit of reading, but not a great deal on this one.
It's one thing I suppose we've got to understand with this is that it's not water in the traditional sense that it is on Earth, whether it be in a lake or in a sea or whatever, or in a puddle. This water isn't exactly like that. It's more on a molecular level, if what I read about it.
Yeah, it's part per million. It's very small amounts.
It's going to be very difficult to access that sort of water. But at the north and south poles, there are many craters that, because of the crater walls, the bottom of them never actually receives any sunlight. And it appears that there is water at the bottom of those, which is in ice form. And that sort of water may be much more accessible. Now, of course, what that means is that we won't have to take water with us up to the moon, because water is heavy, and to transport it to the moon takes a lot of effort, a lot of money, and a lot of power. So if we don't have to take it with us to the moon and can utilize whatever water is there, it makes colonization of the moon a little bit easier and much more palatable for us.
Brilliant answer. Now, Perry, here's another one for you. Viewer suggestion. Let's see the Clavius crater where we've just conclusively detected water on the sunlit part of the moon. Can we get there?
Okay, Clavius, I think, is up towards the top, but I could be mistaken. It's a very large crater, Clavius, and it may be difficult to see when it's full moon. Yeah, but it's probably one of the largest craters, and it's up near the South Pole. For us, in this particular image, south is up, or at least about the 130 position, because of the angle of the moon as it rises. When it's due north in our sky at about midnight, then the south pole of the moon really is straight up. But at the moment, it's to the side a little bit at about the 130 position. Yeah, it's really difficult to make it out.
Would a full view of the moon work better for you, Perry? I've got one now.
Okay, let's have a look at that.
Oh, there we go. It's not so detailed though.
See where the crosshairs are? Can we move that up higher and straight up the middle almost? Yep, straight up from there.
Other way?
The other way, yep.
That's it.
Yep.
So I'm seeing in the chat there somewhere between Tycho and the edge of the moon.
Yeah, it's a little bit further up than that, but it will be really difficult to see. In fact, looking for craters is...
There we go. Apparently that's where it should be, about there.
Yep, that's about right.
Thank you, Ricky.
Looking for craters when it's a full moon is absolutely the most wrong time to be doing it, because when it's full moon, there is no relief on the surface of the moon whatsoever. I'm not talking about the sort of relief of when your football team kicks a goal after a siren to win the match.
That doesn't happen to Carlton, Perry.
Yeah, well, it has. And it's also gone against us once as well. But I'm talking about physical relief where shadows are being cast and the surface features are easier to detect with the heights of mountains and craters much easier to perceive.
So we have another question for you as well. Does the moon move closer to the Earth or away? And could there be a chance the moon could crash into the Earth in the future?
No, the moon, that's an easy one. The moon is slowly, very slowly, I think about the length of a fingernail moving away from us each year.
We've got another one.
It's not going to come back toward the Earth at any point. It's moving away from us.
So Martin wants to know, are there any lava tubes near any of the water deposits? Do we know that?
I don't have any knowledge of that, Martin. Sorry about that.
It's a good question, though.
Yeah, there could be, but I'm sorry, I don't know. The other things that we can say about the moon, though, now that we've got pretty much most of it visible, the diameter of the moon from side to side along the equator is about 3,475 kilometers, which is about a third of what the Earth is, I suppose. And the best time to be looking at the moon is when there's some of the moon in darkness experiencing night and a part of the moon experiencing daylight. The line that separates the day and the night on the moon is called the terminator. And that's where you get the best views of craters, mountains, and the like, because the relief is at its best at that point. Now, also, the other thing to note about that is that on the sunlit side of the moon, the daylight temperature, the midday temperature, is about 100 degrees Celsius. And on the night side of the moon, the temperature is minus 173 degrees Celsius. So it goes from one extreme to the other, from near boiling point to really, really cold and frozen.
I'm not sure what happened to Andy, but he looks like he's being attacked by a spider at the moment. We have another question for you. Will the moon then ever stop orbiting at Earth, and what would be the effect on Earth if it did?
Thankfully, it won't, and it would probably cause a little bit of trouble on the Earth if it ever did do that. Now, the thing to keep in mind is that everything in space and in the universe and in the solar system and in the galaxy is in motion. If it ever stopped being in motion, it really spells trouble.
There we go. Bring that back up to full screen there and have a look at that moon.
The other thing to be mindful about the moon and relate this to Pluto, the moon is larger than Pluto. So from that alone, you can understand why there was a few issues with keeping Pluto as a planet. Can't be a planet if it's smaller than our moon.
Wasn't there an issue with its orbit as well?
Yep, it hadn't cleared its orbit, but that's the new definition. So the moon, we've said the diameter is about 3,470 odd kilometers, 75, 76. whereas the diameter of Pluto is about 2,300 kilometers. So it's quite a deal smaller than the moon, even though it has 5 moons of its own.
I did not know that Pluto had 5 moons of its own, Perry. Thank you very much.
You're welcome, Mark.
I've learnt something tonight. There we go.
Just doing my job, sir.
I've learned a few things tonight, that you still believe that Wayne Harms hit that ball when it was inbounds and kicked that winning goal.
No, it was back in the 3rd or 4th row.
It was in the 4th row and everyone was there, weren't they?
Yes.
Okay, so David wants to know.
It's too late to change it now, Mark.
It's too late to change, not unless I get my DeLorean out. David wants to know, the boiling point depend on air pressure and the moon doesn't have air pressure. Pokey outy tongue as well.
Yep, that is true. So boiling on the moon is quite a bit faster. Well, is it faster? Maybe it's not faster. Maybe it's slower trying to boil something on the moon. But as there isn't any liquid water there anyway, I suppose it's a bit of an academic question.
I think that's all the questions we have for the moment. So have we got anything else you'd like to explain about the moon?
Well, maybe some other things that people may not automatically know about the moon or realize about the moon, and that is the moon is 400 times smaller than the sun, but the sun is 400 times further away from us than the moon is, which means that they both end up being roughly the same size when we look at them in our sky, and hence the reason why we have eclipses.
Well, we have another question. Are the rocks on the moon quite distinct in composition from that of Earth?
They're mainly igneous rocks, but when you get down to examining them very closely, they appear a little bit different to the Earth, to the rocks that we find on Earth. And in fact, that is one of the elements that proves that we must have gone to the moon, because the rocks that were brought back when they were examined by geologists, and I'm not a geologist, but when geologists examined them in minute detail, they discovered that these rocks could not have possibly formed on the Earth. They did have to come from somewhere else.
Okay, so we've got another one as well. Adet wants to know, was the moon a chunk of debris? If so, how did it become spherical in shape?
Another very good question. In the main theory at the moment is that very early in the life of the Earth, as it was forming and still slightly molten, it was hit hard by a body about the size and density of Mars. In that humongous impact, a lot of material was thrown up into space, and it was molten material, which within about 100,000 years, coalesced to form the moon. Now, the moon is spherical because gravity, where the center of the moon, where the heaviest metals went, so all the iron that was in the material that was thrown up into space, found its way or sunk into the center of the moon. And so as the gravity built, the rest of the material that was thrown up from this collision, which in fact material from the Earth, from this impacting body, which is now referred to as Thea, or it's been named as Thea, coalesce together to form the moon. And as gravity pulls in towards the center equally from all parts, it creates a sphere. And the moon is large enough and has enough mass to be able to have its shape be a sphere. But there are anything smaller than about 900 kilometers, 800 kilometers in diameter, doesn't necessarily become a sphere at all. And there are a number of asteroids nearly that size which are not entirely spherical.
Beautiful. So we have another question about what makes it a blue moon for tonight. We know it's not a blue moon tonight because it's not a full moon until, what is it, 1:48 a.m. tomorrow morning? But,
yeah, I think you're right there, Mark.
Yeah. You made me look that one up when we thought it was a blue moon.
Yeah. It happens a lot because most of the material that people find online originates from America or Europe or somewhere else. And so we always, whenever we see that stuff online, we've got to take into account our longitude, I should say, in comparison to the Western hemisphere of the Earth. And in this particular instance, most of Australia doesn't see the moon as full before midnight. And once it's after midnight, it of course becomes November and gives us the opportunity to see a second full moon, which is one of the current criteria, if you like, for declaring something to be a blue moon. And that is the second full moon within the same calendar month. Now, originally, however, that wasn't what made something a blue moon. And it came from the Old Farmer's Almanac from the USA back from a couple of hundred years ago, when farmers needed to know where the full moons were during the harvesting time or the harvesting season, so that they know that they could work later in their fields with the help and illumination from the full moon. So it was an important thing for them to know. Now, normally there are 12 full moons in a year, but every couple of years or every 3 years, there is a 13th full moon. So whenever one of those extra moons falls within a season or the period of 3 months, the third full moon in that season used to be coloured in blue. That may be an apocryphal story, but that's my information. And so because it was coloured in blue and the rest of it was black and white, the farmers would say, we've got a blue moon in late August, we can stay out longer picking our harvest or tending our fields. And so they're the different ways that a blue moon can be named. But back in the 1940s, there was a story in Sky and Telescope magazine that somehow got the original Old Farmer's Almanac criteria for a blue moon wrong and decided to call it erroneously as the second full moon in a calendar month, and it seemed to stick, and so it's now become one of the criteria that declares a full moon being the second full moon in the same, sorry, a blue moon being the second full moon in a calendar month.
Wonderful explanation, and that's what I'd heard, Perry, about the farmers colouring it in blue as well, from what I've read. So that seems to sit right with me as well. Not that I know as much as you, that's for sure. I keep learning.
Please.
So just quickly, we're going to sort of wind it up now, coming on to 10:30. But before we do, next Friday night, next Saturday and Saturday night, we have what would have been our Vic South Star Party, which Perry's heavily involved in as well. In fact, Perry, you're on the committee for that. And unfortunately, we couldn't do that this year. Normally, it's held up at Little Desert Nature Lodge up near Nil in the Little Desert National Park. It had to be cancelled this year, so we're going to do it online, live streamed. We'll have a Sky for the Night with Joe Greeter from the Astronomical Society of South Australia next Friday night, and then we'll do some planet and moon observing and some deep sky as well on the Friday night. And then Saturday we'll have some events, some solar observing, another astrophotography session, a few other sessions in the afternoon. We'll have a quiz, a Q&A, and then another Sky for the Night on Saturday night with Perry, and some deep sky again on Saturday night. So another weekend of events. We've got some more raffles, obviously. We've got some other equipment to raffle off, which will go live throughout the week coming. Also, if you've got a few dollars spare, donate to our Pathways to the Planet's cause. That would be wonderful. And also, we have two views of Mars that we're going to just pop in up on the screen shortly, just for a bit of a good night. We have got some, Gary, we have got some entries for the Halloween pictures, and for everyone else who hasn't posted their Halloween picture yet, we're going to close that membership competition off at about midday tomorrow. So you've got a bit of time for that. So if you've got a costume you want to chuck on and take a photo and post it in the chat, in the post that's on our Facebook page, that would be great as well. And whoever we deem to have the best outfit will get a 1-year subscription, a 1-year membership if you don't already have one. Or even if you do have one, you can just get an extension of it. So we'll have a look at the costumes and pick a winner. And Noel, thank you for this lovely image of Mars. I know Ron's got one up as well. So I thought we'd just leave you with that one, because you know it's Mars season at the moment and it's looking pretty good. So thank you everybody for coming along. Yeah, Uncle Fester, Ricky says you should win the dress-up competition. Unfortunately, you're not allowed to. You're gonna end up being one of the judges, because Uncle Fester's part of our social media team. Would you believe it? Thank you everybody for coming along, and we will see you all next Friday night for another live stream.
Good night.
Good night, everyone.